See how we're in section 6.3 here, and what we're doing here is factoring what we call hard trinomials. Let me go ahead and put quotations around hard. If you watched my previous video, the trinomials I did there I always referred to as easy. And again, what I said in that video was that they're not necessarily easy, but relative to the amount of work that's required to factor these here in this section, they are considered to be a little bit easier. Now these are the ones in this section are considered to be the hard trinomials. And the reason they're considered hard again is because there is a little more work involved in getting them factored out. What I wrote right here, first off, is the name of the method, AC grouping. There are different methods that you can use to factor these hard trinomials. There is trial and error. There's what's called the box method. There's what's called tic-tac-toe method, just different things you may have learned previously, and if you want to use those things, that's fine. I'm just going to teach you this way right here, and if you want to use it, you definitely can. I'd love to see you use it because it always works if you do it correctly. Now what you see here are 4 basic steps. That's what I have here. These are steps for factoring using AC grouping method. This AC, I'm going to explain. It basically means multiply the first number in the problem times the last number in the problem. The phrase numbers that work refers to finding 2 numbers that multiply to the AC and add to the middle number. And again, I'm going to show you all this in just a moment through an example. Third, you will split the middle using those numbers that work. And fourth, since you have split the middle, you'll have 4 terms instead of the initial 3 that you started with. And if you have 4 terms, you can factor by grouping. So let's go ahead and get started. We'll work through several examples here. Let me mention that the key characteristic of these types of trinomials is that the lead coefficient in these is going to be something besides 1. So like for example, 2x squared plus 7x plus 3. You always look for a GCF first, and if there's not a GCF, you look at the first number. If it's a number besides 1, then you're going to know that you are dealing with what we call a hard trinomial. Okay, so we've already established, or I think we can conclude, that indeed we are dealing with a hard trinomial here. So we're going to use the AC grouping method. Now if you want to look back at the previous slide, AC in this problem would be 2 times 3. AC is first number times the last number, and that's going to be 6. And I'm just going to write the 6 over here on the side. The second phrase is numbers that work. The numbers that work would be 2 numbers that multiply to 6 and add to 7. And in this case, those numbers would be 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. Third thing is split the middle. What that means is take this middle term here and split it up using 6 and 1. Now since it is x term, we're going to say 6x plus 1x. And what we do is we just bring the other numbers straight down. That will give us 2x squared plus 6x plus 1x plus 3. So you can see we've got the same problem here, meaning the same same problem as we started with, meaning this and this are the same problem. It's just that we chose to take 7x and split it in 2. Now what that does is it takes us from having 3 terms in the problem to having 4 terms in the problem. Let me rewrite the problem without all that scribble around it. And we've learned previously that when you have 4 terms, you can factor by grouping. So out of the first group, we're going to take 2x. Out of the second group, we're just going to take a 1 out. If you do look at a group and there's no GCF, just put a 1 there, and that would serve as your GCF. And when you take 2x out, you have 2x times x plus 3. And then take a 1 out, it's still going to be x plus 3. And you'll remember that when you did grouping, if you did it correctly, these parentheses would always match, and that's also the case here. And also remember that when you did grouping, when you had the matching parentheses, you would take these 2 terms, put them together in the same parentheses, and then bring down the matching parentheses. And that gives you your final answer, which is 2x plus 1 times x plus 3. Let's go ahead and look at another one. You have 2x squared plus 19x plus 35. What I would like for you to do now is to pause the video and see if you can work this problem and work it the same way you just worked the one on the previous example. Okay, so I hope you tried to work it, and if you follow the same process, the first thing you'll do is write the number 70 down. And again, why are we writing 70 down? Because if you say A times C, you get 70. 2 times 35, and now we need two numbers that multiply to 70 and add to 19, and those numbers will be 14 and 5. So we're going to take the middle and split it into 14 and 5. So we took 19x and we're splitting it and bringing the end numbers down. We'll factor by grouping. That will leave me with 2x times x plus 7 plus 5 times x plus 7. The 2x plus 5 match, or go together, excuse me, because the parentheses match, and you end up with 2x plus 5 times x plus 7, and that will be your final answer on that one. Let's look now at 3x squared plus 14x minus 5. And again, feel free to pause the video and try to work this out, and then we'll work it together. So if you've worked it, let's go ahead and try it together. AC here would be negative 15. That's the first time we've done this with this negative, but again, when you do the first times the last, you have to take the signs into account. So it would be 3 times negative 5, which will be negative 15. The numbers that work here would be 15 and negative 1. And again, think about that for a moment. 15 times negative 1 is negative 15. And 15 added to negative 1 is positive 14. So those numbers work. So again, when you find out that those are the numbers that work, we will take the middle, this, and split it into 15x minus 1x. We'll factor out a 3x out of the first pair. And the second pair is going to be negative 1. Really important that you notice again the negative right there. That means your GCF here will be negative as well. So you have 3x times x plus 5 minus 1 times x plus 5. Just like always, the parentheses match. You end up with 3x minus 1 times x plus 5. We'll try one more of these before we do a GCF example. 6x squared minus 17x plus 12. Right here your AC is going to be 72. 6 times 12. The numbers that work will be negative 8 and negative 9. You take 6x squared, split up negative 17x minus 8 and minus 9. And by the way, I need to mention this. It doesn't matter the order that you split them up. I could very easily do negative 9 minus 8. It's going to look a little different in the process of doing it, but you will end up having the same answer in the end. So don't worry about which order they should be in. Just split them up using the right numbers and you'll get the correct answer if you do the rest of the problem correctly. So take 2x out of the first pair, take negative 3 out of the second pair. That'll be 2x times 3x minus 4, and then minus 3 times, I copied that wrong right here, that should have been plus, minus 3 times 3x minus 4. That gives you 2x minus 3 times 3x minus 4. Okay. The last one I want us to do is let's do 15x to the fourth minus 39x cubed plus 18x squared. Now, just like any factoring problem, you want to sort of notice if there's something weird going on, like a GCF. In this case, you can, I think, pretty easily spot that there's some things going on that are not like the other problems, like it starts with a fourth power and goes to 3 and 2. And I hope you also notice that the 15, the 39, and the 18 all have a common factor as well. So overall, the GCF here, which we need to take out, would be 3x squared. Take 3x squared out, that's going to leave behind 5x squared minus 13x plus 6. So you take the GCF out and you still notice that you've got a hard trinomial. And so we'll go ahead and do the AC method on what's inside the parentheses here. So A times C here would be 30. The numbers that work would be negative 10 and negative 3. And again, negative, negative, because it's positive 30, but it adds up to negative 13. And then you'll take negative 13 in the middle, split it into 10 and 3. We'll take 5x out of the first pair, negative 3 out of the second pair. So that'll be 5x times x minus 2 minus 3 times x minus 2, and gives you 5x minus 3 times x minus 2. The only thing is, don't forget the 3x squared, your GCF. I sort of left it off right here, but it is still part of your answer, so make sure you bring it down, and your final answer to this problem would be that right there. You know, the hardest thing about this may be finding out the numbers that work. We talked about that a little bit with the easier trinomials, just a strategy for finding numbers that work. Let me remind you of that strategy, backing up to the previous problem. You have 72 on this problem. We've already worked it, but just to show you the numbers, let me come down here in the left corner, bottom corner, and write this 72. I'll make him fit this here. You know, what are all the things that multiply to 72? You got 1 and 72, 2 and 36, 3 and 24, 4 and 18. I'm going to run out of room probably. 6 and 12, 8 and 9. Now again, I didn't put the negatives here, but the thing you want to do is decide which type of sign combination you're going to be working with before you even start this process. It's a positive here and a negative here. That means you're dealing with a negative, negative. How do I find these numbers here? I mean, you know, you may can do them in your head, but if you can't do them in your head, just do them on a calculator. Alright, so just start with 1. 72 divided by 1 is 72. 72 divided by 2 is 36. 72 divided by 3 is 24. 72 divided by 4 is 18. You notice I didn't do 5 because if you do 72 divided by 5 on your calculator, you get a decimal, so we don't do 5. 72 divided by 6 is 12. 72 divided by 7 is a decimal, so don't use 7. 72 divided by 8 is 9. Now, you'll notice that I'm through, and how do I know I'm through? Because those numbers are close together. When the numbers get close together like that, you know you found every combination. So after that, you look for the combination that adds up to 17. And you can see it, that's it right there. So you don't have to guess on numbers. It may take some people longer than others, but you can still find the numbers that work. Just come up with a way that works for you using your calculator and stuff, and you should be able to find the numbers that work on almost any problem, even with big numbers. There are a few examples in here of problems with big numbers. There's one in the book, and I may go ahead and do this since I'm on the subject. It's number 36 in the book. You have 16y squared minus 46y plus 15. Now, a lot of problems I work, I already know what the numbers are because I've done these before. But this one I look at and I don't really know what the numbers are. So let's try to figure this out together. This is an AC problem. There's no GCF, so we're going to go ahead and do AC 16 times 15. I'm going to get my calculator and see what is 16 times 15, and it's going to be 240. Now, that's obviously a bigger number. So what am I going to do? I want to find the numbers that work. So I'm going to start with 1. What would that match up with? It would match up with 240. Then I'm going to do 2. 240 divided by 2 is 120. Then I'm going to do 3. 240 divided by 3 is 80. Then I'm going to do 4. 240 divided by 4 is 60. Then I'm going to do 5. 240 divided by 5 is 48. And then I'm going to do 6. 240 divided by 6 is 40. And you don't have to do every combination. When you run into the one you want, you use it. Okay, and again, what sign combinations am I wanting here? I've got a positive here and a negative here. That means I need a negative negative. So you could, if you wanted to, put negatives on all these. And there you go, you found your combination. So even with big numbers, that's not a reason not to do a problem or to struggle with it. If you just have a consistent approach to finding these numbers, we'll go ahead and do this since we know what the numbers are. It'd be minus 6y minus 40y plus 15. 16 and 6, the GCF would be 2y there. 40 and 15, the GCF there will be minus 5. So 2y times y minus 8 minus 5 times y minus 8. The parentheses match just like they always do, and your final answer is 2y minus 5 times y minus 8. So these are good problems. There's several steps to them, but I think you can do them if you'll just do them all the same way. Always use the same approach on every problem of this type, okay? Let me know if you have any questions. Thanks.